recording.
So you all pay attention to Alex now as he explains how to get GM out of this data.
So for our plot, we did tangent of the angle on the x-axis, and then we did the weight times the distance on the y-axis. And then when you do the equation for GM, it's GM equals WD over displacement times tangent in the angle. So since the displacement is constant in this one, we don't have to worry about that until we pull the data off. So on this one, I plotted plotted the data points. So then what we do to find the trend line or the line of best fit and then the equation of the line of best fit is we left click the chart that we made, then we go to the green plus, we go down the trend line, and then we select trend line, and that generates the line of best fit for all of our data points. And then we come down over here to the arrow at trend line, and then we go to more options. And then over here on the right it says display equation on chart. Select that, and that will give us our y equals mx plus b, our slope, and our intercept. So we can see here it's 43.178. So that's WD divided by tangent of theta for our trend line, and then we'd have to divide that number by the displacement to get our GM with the inclining weight. Yes.
Will you describe the units that you have to get GM?
Okay. So our GM with inclining weight right now is the equation WD over tan theta. W is going to be kilograms, D is going to be centimeters. Degrees are unitless, so right now this number right here, 43.178, is kilograms centimeters, and then we divide by the displacement, which is in kilograms, so we get centimeters for our GM. Yes.
Will you explain how you converted to take the tangent of the angle in Excel?
Okay. So during the lab, we recorded we recorded it in degrees. So to get to radians, because Excel reads in radians, you have to come over here. You type in equal sign to make an equation, and then you type in pi with closed parentheses to generate 3.14 to the 15th decimal point, and then you multiply it by the cells that have degrees and then divide by 180. So in turn, you're actually just multiplying your degrees by pi over 180 to make it radians, and then you take the tangent of that by typing in TAN with the parentheses, and then that D3 is our radians. Yes?
Oh.
Explain how you got a graph that went from quadrant 1 to quadrant 3.
Oh, okay.
Oh.
So it's arbitrary. You could do port or starboard as that, but
Your incline weight, it should be 2.105.
oh, it should be
Yeah.
2.105.
Yeah.
Okay, maybe that's
There you go.
there we go. So now I'll have that makes a lot more sense. So scratch everything.
The calculations are good.
Yeah, it was just, so our inclining weight was 2.105 kilograms instead of 0.2105 kilograms. So that changes our GM by a factor of 10. So now we'll have a GM close to 10 centimeters instead of 1 centimeter. So, good job. So, where was I?
Quadrant 1 and 3.
Oh, quadrant 1 and 3. So the way we did it is port and starboard, and if you were to graph them without changing anything, you'd have two lines going in the quadrant 1. So to make it so quadrant 3 is reflecting port side, we changed the degrees for port side to be negative, and we changed the weight times distance to be negative. So when you have two negatives, it'll be in quadrant 3, and when you have two positives, it'll be in quadrant 1 to make it a straight line.
Will you finish up the calculation on Excel now?
Yeah,
For
sure.
what is GM?
So
Show us how you do that.
our GM value, must be seen. Yeah, it can be seen. Alright, so the GM value, since it's the equation WD over displacement times tangent theta, is going to be, if we go to here, we found our displacement for 0.0765 meters is going to be 40.0321. So to get our GM, we're going to do this number right here, right here, 431.78, so 431.78 divided by the number over here, 40.0321. And we got a GM of 10.79 centimeters.
And label that's GM with the incline weight.
There we go.
Good. Spencer, I think we're done with recording now. Thank you, Zach, Alex, and Spencer.